Okay, today our topic is limits. Okay. Before going in depth, let me cover basics of limits. Neighborhood of limit. Neighborhood of a real number. So consider a real number. Consider a real number A on the real axis. Let's take this is a point A on real axis. Okay. Now let's frame a question. Let's frame a question. Okay. What is the smallest interval you can keep A? Means my question is, what is the smallest interval you can place A? Like, what is the smallest interval you can place A? Okay. For this, look, this is what this is, that is how close we can move towards A. That is moving either from left side or from right side. Of A. Okay. What is the smallest interval you can keep A? Smallest interval we can keep A. This is how close we can move towards A. Either approaching from left side or from the right side. Let's explain through diagram. Let I am approaching from the left side of A. Let's take I approach till this point. Okay. And let's approach from the right side of A till this point. Okay. Then this is the smallest interval that I can keep A. Okay. So let's go forward. Since we don't know how much exactly we can approach, so let us consider an interval. a minus delta to a plus delta. Since we don't know exactly till what point we can approach, so let us consider the interval we can approach is from a minus delta to a plus delta, where delta, first one, delta is positive, the second one is delta is infinitely small real number. ठीक है, delta is positive and then delta is infinitely small. Infinitely small means that is very very small. So let's represent the diagram. So on the number line we can represent again. This is A. I am approaching from the right side of A till this point. Let's take example, I approach from this point till this point. And this is A plus delta, because delta is positive, A plus delta is greater than A. And let's approach from the left side of A, and I approach it till this point, A minus delta. This is A minus delta, A on the number line, A plus delta. And this distance is delta, this distance is delta, and delta is real number. Okay, and this is the interval I assume that I can keep A minus delta, A plus delta. If you zoom out this, still you will get infinite number of real numbers. Okay, and so that's why delta is very very small. So now, so let's conclude. Let's conclude neighborhood of A. Neighborhood of A, all real numbers, all real numbers existing between A minus delta and A plus delta is called neighborhood of A, NDD of A, where delta is radius and we can represent neighborhood of A as n delta A. Neighborhood of A equals to A minus delta to A plus delta equals to all x belongs to R, A minus delta to A plus delta. So this is our conclusion with neighborhood of A. Okay, okay, let's go forward. So let x be the real number which is not exactly A. Means they are saying that x is a real number and which is not exactly A. Okay? Means x is not exactly A, but just slightly lesser or greater than a means x is not exactly a but slightly lesser or greater than a. So we can write it as x tending to a, and we can read it as x approaches a point a. ठीक है, see this is a, and if I am approaching from the, okay, this is how I approaches towards a, either from the left side either from the right side. So we can talk direction sense x tending to a. ठीक है, now case 1, when x is moving from negative x-axis direction to positive x-axis, मतलब x is moving in this direction, then we can write x is approaching a towards in the direction from a minus, x is approaching a minus. Okay, so we can write as x tending to a minus or x approaches a minus. Okay, x is not exactly a but approaching towards a minus. This is a minus. A minus is slightly less than a. Okay, and case 2, x is tending to a plus means x is not exactly a but tending to a plus from right side, मतलब it is moving, we are going from right side but we are approaching a plus. This is a plus. Okay, so we can write it as x tending to a plus, and we can read it as x approaches towards a plus. Okay, and okay, this is what left neighborhood of a, because it is in the left side now, so it is left neighborhood of a x tending to a minus. So this whole neighbors are left neighborhood of a, and this is right neighborhood of a. Okay, similarly these points, since it is approaching from the right side towards a plus, so we can write it as, we can say it as a right neighborhood of a. So let us consider an example f x. Okay, limiting, our neighborhood of a real number finished. Now I am going to limiting value of a function. Limiting value of a function f of x. So let us consider f of x equals to x square plus 3. ठीक है, of x equals to x square plus 3. Now question, let's frame question. What is the value of f of x at x equals to 2? At x equals to 2, f of x equals to f of 2 equals to, from the equation we can write, okay, from the equation we can write, we can substitute 2 there, 2 square plus 3, which gives 7. Okay, all right. So our second question is, what is the value of f of x as x tending to 2 minus, not exactly 2 but 2 minus, x is approaching 2 minus from the left side of the number line. Okay, means this is 2 and x is approaching from this side towards 2 minus. So this we can write as limit x tending to 2 minus f of x equals to limit x tending to 2 minus x square plus 3. So when we are approaching from the left side of the 2, means limit x tends to 2 minus f of x equals to limit x tends to 2 minus x square plus 3. This is what we call, limiting value of a function f of x. Okay, this is what we call limiting value of a function. हमारा definition, हमारा heading. So similarly if you value of x when x tending to 2 plus, means x is approaching from the right side of the 2 towards 2. Okay, this is number line, this is 2 and x is approaching from the right side of the 2 towards, and we can write as limit x tending to 2 plus, as we discussed before board, and this we can write as limit x tending to 2 plus f of x equals to limit x tending to 2 plus x square plus 3. And before we got what we got, before we got from approaching, when we approach from the left side, we got limit x tends to 2 minus f of x equals to limit x tends to 2 minus x square plus 3. And this is what we call left hand limit. This is what we call right hand of a function and this is what we call left hand limit of a function. ठीक है, LHL, RHL, LHL, left hand limit and right hand limit of a function. Okay, this is what we call limiting value of a function. Okay. So let's go forward and let's calculate that limits. Okay. So limit x tends to 2 minus f of x, we got limit x tends to 2 minus x square plus 3. Since x approaches 2 minus, means x approaches 2 minus means it is approaching from the left side. So means x is less than 2. So we introduce a new quantity. X can be x equals to 2 minus is replaced by 2 minus h. Okay. Where okay, since x is approaching towards 2 from left side, and the number line left side are less than 2 and right side quantities are more than 2. Since x is approaching towards left side from left side, so x minus x is less than 2. So we can, I want to represent it as x equals to 2 minus equals to 2 minus h, where h is positive real number, positive real number. Second one, h is infinitely small quantity. H is positive and h is infinitely small. If h is positive here, then 2 minus h is less than 2, which is x minus. So let us try to answer this. So we can write it as limit x tends to 2 minus f of x equals to limit, substitute h tends to 0, f of a minus h. ठीक है, since in place of a we have 2, so limit x tends to 2 minus f of x equals to limit h tends to 0, f of 2 minus h. Okay, so let's substitute there. Remember this formula. Let's substitute 2 minus h here in equation 1. So limit x tends to 0, f of 2 minus h equals to limit h tends to 0, 2 minus h whole square plus 3 equals to 2 square 4 plus h square minus 4h plus 3 equals to 7 plus h square minus 4h. Since since h is very small, let's take example h is 10 power minus 35, means this goes to, let's take example h is 10 power minus 35, means h square is 10 power minus 70 minus 4h minus 4 into 10 power minus 35, means this is compared to 7, these two are very small quantities, so we can write it as h 7 plus 0, approximately this is h7. So we got limit x tends to 2 minus f of x equals to limit h tends to 0 f of 2 minus h equals to 7. Notice what is the note point? This is not exactly 7. This is not exactly 7, but slightly less than 7. Why? Because you can see here h square, because of this extra quantity h square minus 4h is 10 power minus 70 minus 4 into 10 power minus 35. 4 into 10 power minus 35 is always greater than 10 power minus 70, so this is a negative quantity less than 0. So 7 plus negative quantity is less than 7. समझ में आ रहा? 7 plus negative quantity is slightly less than 7, and so that is our node point. Similarly, limit x tends to 2 plus x square f of x equals to 2 plus, we can write replace as x tends to 2 plus, we can replace as 2 plus h. Before we written 2 minus x, 2 minus h. Now we are writing it as 2 plus h. Okay, here h is a positive quantity, so 2 plus h is greater than 2, slightly greater than 2, and we know x is also slightly greater than 2, so we can write as x equals to 2 plus h. Okay, so limit x tends to 2 plus f of x equals to limit h tends to 2 plus f of 2 plus h equals to, substitute f of x 2 minus h 2 plus h whole square plus 3, 2 square 4 plus h square plus a plus b whole square plus 3. Okay, and 4 plus 3 7, this is 7 plus h square plus 4h. Now since h tending to 0 and h square tending to 10 power minus 70, we take an example h equals to 10 power minus 35. So h is h square tending to 10 power minus 20. 4h tending to 4 into 10 power minus 35. Okay. So this is almost equals to 7. Because these are very small quantities compared to h square and 4h. Compared to 7, h square and 4h are very small quantities compared to 7. So the value is almost 7. But we can see here, this is that value, limit x tends to 2 plus f of x square plus 3 is not exactly 7 but slightly greater than 7. Why? Because here you can see we got the result. H square is positive quantity as h is positive and this is positive. So 7 plus positive plus positive plus positive is somewhat greater than 7. So we got like this. So limiting value is not exactly 7 but slightly greater than 7. So we can represent that as in graphically. You can represent that in graphically. This is a number line. Okay, this is our 2 and we are approaching from the left side of 2 and we approach it till the distance 2 minus h. Now from the right side we approach till 2 plus h. This is h distance, this is h distance, and for 2 our limit value is f of 2 equals to 7, and for 2 plus we got 7 plus k. Let's take example k. For 2 minus we got 7 minus, let's take example 7 minus k, and this is k distance. So we can conclude from here, as x approaches, as x varies between 2 minus h and 2 plus h, then f of x varies between 7 minus k comma 7 plus k. What is k here? What is k here? You remember we got limit x tends to 2 plus 7 plus h square plus 4h. This extra quantity is k. Okay, this difference between 7 and is h square plus 4h. Okay, every time it is not possible to find k, but sometimes. So that is our limiting value of a function. So let's take, so in above example we took f of x which is defined everywhere. So let's consider f of x which is not defined, not defined everywhere. Let's take it. F of x equals to rho of x equals to x square minus 1 by x square minus 3x plus 2 when x not equals to 1, when it equals to 2, when x equals to 1. So clearly you can see that this f of x is not defining at x equals to 1. If you give x equals to 1, it is undefined, it is going to infinity. Clearly you can see x is f of x is not defined at x equals to 1. Okay, so let's find limits when we approach from the left side and right side. Let's find limit x tends to 1 minus f of x. We can replace x tending 1 minus as 1 minus h, where h is positive quantity. So we can write it as limit h tends to 0 f of 1 minus h. Okay, since x tending from 1 minus, this is x equals to 1, x tending to 1 minus or 1 plus we can take from here. Okay, this is x equals to 1 and x is defined, f of x is defined for all values of x except x equals to 1 here, and this is at exactly x equals to 1. At exactly x equals to 1, f of x is 2. Okay, so substitute 1 minus h here, 1 minus h, 1 minus h whole square minus 1 minus 1 minus h whole square minus 3 into 1 minus h plus 2 equals to, numerator we can write it as 1 plus h square minus 2h minus 1 divided by, numerator we can write as 1 plus h square minus 2h minus 3 plus 3h plus 2. 1 minus 3 plus 2 cancel out, 1 minus 1 cancel out. What we left with, h square minus 2h by h square plus h. ठीक है, since limit h tending to 0, numerator here, since h is not exactly 0. Okay, I said what I said. The first thing I said is h is positive real number. The second thing I said is h is infinitely small quantity. ठीक है, so if you observe here, h is not exactly 0 but positive. What does it mean? What we can infer from here is very very important. Okay, h is not exactly 0 but positive. If you divide something by 0, if you divide 0 by 0, it is undefined. We can't divide 0 by 0. But if you divide something 0, something tending to 0 just greater than 0 plus 0, 0 plus by 0 plus, this is not exactly 0, this is not exactly 0, so we can, but there these two are same quantities, then it is equal to 0, then we can divide that. Okay. Equals to 1, 0 plus by 0 plus, we can divide. Okay. So here h is not exactly 0, but it is just positive quantity. Okay. So we should, this is very very important point. Okay. So here you can take h common to cancel it. H common, h minus 2, this is h plus 2, h plus 1. So since it is not exactly 0 by 0 but tending to 0 by tending to 0, we can cancel it out. Okay. So cancel कर दिया. So since h is tending towards 0, so this we can write as, it is definite now, 0 minus 2, 0 plus 1. Here we can substitute h, before we can't substitute because there we are getting 0 by 0 form. But here after cancelling you are getting definite by if you keep 0 here you are getting definite by definite, so we can substitute h here. So this gives minus 2. So we got limit x tending to 1 minus f of x equals to limit h tending to 0 f of 1 minus h equals to minus 2. Okay. Similarly we can find limit x tends to 1 plus f of x equals to limit x tending to 1 plus can be replaced by 1 plus h, so limit h tends to 0 f of 1 plus h equals to 1 plus h square plus 1 plus h whole square minus 1. 1 plus h whole square minus 3 into 1 plus h plus 2. Plus h square plus 2h minus 1 by 1 plus h square plus 2h minus 3 minus 3h plus 2 plus 2 minus 1 plus 1 can be cancelled. Okay. So what is the remaining term? Minus 1 plus 1 cancel here. H square plus 2h by h square minus h. Limit h tending to 0. Okay. So again same, you take h common here, h plus 2 1 minus h minus 1 Okay, cancel out h. So limit h tending to 0. Substitute 0 now. You can substitute now. 0 plus 2 by 0 minus 1 equals to minus 2. So we can conclude now. Right. So we got left hand limit x tending to 1 minus f of x equals to the next time to minus equals to minus 2. Right hand limit x tending to 1 plus f of x, we got minus 2. But before we return, f of x equals to x square minus 1 by x square minus 3x plus 2, x not equals to 1, and it is 2 when x equals to 1. Here, if you observe carefully, we got limit tending to 1 minus and 1 plus. We got limits minus 2 minus 2. But x equals to 1 and x equals to 1, we got they given f of 1 equals to 2. Means when I am approaching from the left side of 1 towards 1 minus, my value I got left hand limit minus 2. And when I am approaching from the right side of the 1 towards 1 plus, I got value minus 2. But exactly at 1, I got a value of 2. So what we can say, means limiting value is not same as function at point 1. You can see by graphically at x equals to 1, I got f of 1 exactly 2 and x equals to exactly 1. Okay, but limit extending to 1 minus is 1 minus h, and limit extends to 1 plus h, 1 plus, I got limit value equals to minus 2 and equals to minus 2. Okay, and suddenly it shifted here, from here to here and again here. Okay, so at exactly 1, we got f of x equals to at exactly 1 minus h, this point, this point, this point, exactly 1 minus h we got minus 2, and exactly 1 plus h we got plus minus 2. Well, at x equals 1 we got plus 2. Means limit to 1 equals to not same as of 1. So okay, now come to the existence of the limit, condition for existence of the limit. Existence of limit, if f of x is said to be exist at any point x equals to a. Limit if, then it must satisfy limit x tending to a minus f of x, limit x tending to a plus f of x. ठीक है, means existence of the limit f of limit x tends to a f of x is said to be existence if and only if when the left hand limit x tends to a minus f of x equals to the right hand limit x tends to a plus f of x. Okay, when left hand limit is equal to right hand limit, then we can say limit exist. So in before example we got left hand limit equals to limit x tends to left hand limit x tends to 1 minus f of x equals to minus 2, right hand limit f of x equals to minus 2. So LHL equals to RHL equals to minus 2. So we can say limit exist at x equals to 1. Okay, so limit exist at x equals to 1 in the before example. Before, because left hand limit equals to r and right hand limit equals to minus 2. Here you should note one point. This is a note point for limit to exist at x equals to a. It need not to be defined at x equals to a. Means in before example you seen that f of x is not defined at x equals to 1. X equals to not x not equals to 1, x square minus 1 by x square minus 3x plus 2, x equals to 1 is 2. Means f of x is not defined at x equals to 1. So but we seen limit LHL equals to minus 2, RHL equals to minus 2, and both are equal, so we said limit exist. So from this we can say for limit to exist at x equals to a, it need not it is not defined at x equals to 1 because infinity, it is tending to infinity. Need not defined at x equals to a, but still limit exist. Okay, okay, and this is our theory for today. So let's solve some problems. Let's solve some problems. Question number 1. Question number 1. Limit x tending to 3 minus x minus 2 by x minus 3. So x tending to 3 minus. Okay. This is 3 and x is approaching 3 minus from left side of x, left side from x-axis. Okay. So I already said that x tending to 3 minus we can write it as x equals to 3 minus h. Okay. And this we can write it as limit h tending to 0 f of 3 minus h equals to 3 minus h minus 2 by 3 minus h minus 3. Okay. So you can cancel 3 numerator, 1 minus h by minus h. Okay. So if you see this, okay, 1 minus h numerator, this is tending to 0, so 1 minus h tending to 1. And if you see denominator, this is positive quantity. I said h is positive quantity. H is positive quantity. So minus h is just less than 0. Very, very small, but less than 0. So this is, we can write as 1 by something less than 0. Minus 0. Okay. Because h is positive quantity. So this is definite. This is 0. 1 by 0 we can say it is minus infinity. 1 by 0 infinity and minus sign, so minus infinity. So we got limit x tends to 3 minus f of x equals to minus infinity. Okay. Clear? Let's go to second question. Question number 2. Our second question is prove limit x tending to 2 step x does not exist where is greatest integer function. Step x is greatest integer function. ठीक है. So note point, you can note here once. Note point is whenever question asks limit x tends to 2 minus, just asked before example we got limit x tends to 3 minus, just then find only this limit x tend to 3 minus. Okay, but when our question asked limit x tending to 2 without any symbol here, okay, without any symbol positive or negative here, just ask 2, then you should find both left hand limit and right hand limit. After finding both left hand and right hand limit, if left hand limit and right hand limit are equal, then only we can say limit exist. Okay, if not, limit does not exist. So in this question they ask to find limit extends to 2 without keeping any sign. So limit extends to 2, we can write divide into two cases. Case 1, limit extends to 2 minus left hand limit step of x equals to the first part 1, limit h tends to 0, 2 minus h. Okay, since I said h is greater than 0, positive quantity, now let's take example h is just greater than 0, means h is, let's take example 10 power minus 35, means 2 minus h is equals to 1.9999 up to 34 digits, here something 9. Okay, this is what we got, 2 minus h quantity. So this value we can write as step of 1.999999 equals to, we know that step of something less than next integer is 1. Okay, so limit x tends to 2 minus step x is 1. Similarly, now we will write part 2, limit x tends to 2 plus step x equals to limit x tends to h tends to 0, 2 plus h, as h I said example 10 power minus 35 is 2 plus h equals to 2.0000 something 1, it is greater than 2, so we can write it as 2.000001, step of 2 plus something equals to 2. So we got left hand limit equals to 1, right hand limit equals to 2. So from the we can say left hand limit not equals to right hand limit, which means limit does not exist. Okay, so we found both limits and we see limit does not exist. They ask limit extends to 2, we should find both limits and we should say limit does not exist. Okay, because left hand limit is not equals to right hand limit, this is 1 and this is 2. Okay, let's go to third question. What a quick. of x equals to x plus 1 if x greater than 0, x minus 1 if x less than 0. ठीक है. Okay, so let's find limit. They ask limit x tends to 0 f of x. They ask x tend to 0, so we should find both limits, left hand limit and right hand limit. So left hand limit equals to limit x tends to 0 minus f of x equals to limit h tends to 0 f of 0 minus h. F of 0, limit h tends to 0 f of 0 minus h. This is less than 0 quantity, okay? This is greater than 0, so f of 0 minus h. X tends 0 minus comes under this domain, 0 minus h. So 0 minus h minus 1. Since h tends to 0, it is minus 1. Okay. Similarly, right hand limit h tends to 0, 1 plus h plus 1. Okay, h plus 1. This is plus 1. So we can say LH is equals to minus 1 or H equals to plus 1. Limit does not adjust. Limit does not adjust. Let's go to fourth problem. Prove limit x tends to 0 minus x square minus 3x plus 2. Sorry, x square minus 3x plus 2 minus by 2x square. So again, this is they ask just 0 minus, so no need to find right hand limit. Okay, yeah, so 0 extended 0 minus we can write as 0 minus h. So limit h tends to 0, f of 0 minus h, 0 minus h whole square minus 3 into 0 minus h plus 2 by 0 minus h whole cube minus 2 into 0 minus h whole square. So prove, what is the question? Prove limit does not adjust. Sorry, prove limit does not adjust. Limit does not adjust. Okay, both limits. So minus h square positive, positive square positive, 0 h square, and minus 3 plus 3h plus 2 by minus h cube. Since h is positive quantity, so h cube positive minus cube minus 2 h square. Okay, so this we can write as h square plus 3h minus 1 by minus h cube minus 2h square. ठीक है, सॉरी यहाँ 3 नहीं आता क्वेश्चन. Okay, sorry, this is not 3 minus 3 minus into minus plus. Okay, now it is all right. Okay, now okay, so h square plus 3h minus h square plus 3h plus 2, this is our requirement. So h tends to infinity. Now when you keep h equal 0, 0 plus 0 plus 2, 0 cube plus 0, this is definite by indefinite, minus 2 by 0, something tending to 0 equals to minus infinity. Question is actually tending to 0 minus only, so our limit is minus infinity. So let's put a quick next question. Evaluate limit x tends to 0 mod x by x. So first one, limit x tends to 0 minus mod x, 0 minus h by this is equals to 0 h 10. Left hand limit we can take, we are taking 0 means it is 0 minus h, mod of minus h, mod of minus h is, since h is positive quantity, mod of minus h is plus h, and 0 minus h is minus h equals to minus 1. Okay, similarly limit x tends to 0 plus mod x by x, first limit h tends to 0 mod x is 0 plus h by 0 plus h mod, since h is positive quantity, 0 plus h is h by h equals to 1. So left hand limit we got minus 1, right hand limit we got plus 1, so limit does not exist. Limit does not exist. Limit x tends to 0 f mod x by x does not exist. Let's go to sixth question. F of x mod of x minus 4 by x minus 4, x not equals to 4. 0 1 x equals to 4. Left hand limit, let's find left hand limit. X tending to 4 minus equals to limit h tends to 0. This is 4 minus h minus 4 by 4 minus h minus 4. Cancel out, cancel out. Mod of minus h equals to plus h. Since h is positive quantity and this is minus h equals to minus h, means left hand limit is minus 1. Okay. Similarly, right hand limit h tends to 0. Mod of 4 plus h minus 4, 4 plus h minus 4. This is plus 1. Means left hand limit is minus 1 and right hand limit is 1, so we can say limit does not exist. Next question. Next question is 7th question. F of x equals to 1 plus x square 0 less than x less than 2 minus x greater than. Show that limit does not exist at x equals to 1. Does not exist at x equals to. Show that limit does not exist at x equals to 1. So left hand limit x tends to 1 minus f of x equals to 1 plus limit h tends to 0 f of 1 minus h equals to 1 plus 1 minus h whole square. 1 plus 1 plus h square minus 2h equals to 2. Left hand limit is 2 and right hand limit h tends to 0. 2 minus 1 plus h equals to 1 minus h equal to 1. So right hand limit, they are not equal, so limit does not exist. So let's go to 8th question. F of x equals to cos x greater than 0 mod x plus a x less than 0. What is a? When find a if limit exists at x equals 0. So let's find next left hand limit h tends to 0 cos of step of 0 minus h. This is cos question step of x cos step of Okay, 0 plus. Okay, this is 0 plus 0 plus h. Okay, so cos something, cos 0 plus, which is positive. Step of 0 plus is 0, so cos 0 is 1, and limit extends to 0 minus. The extends to 0 minus, limit h tends to 0, mod of 1 minus h, 0 minus h plus a equals to positive quantity mod h plus a. Since a is h equals 0, so a. So since they said limit exists, means LHL equals to RHL, means a equals to 1. So